Today we are looking at adding and subtracting polynomials. It's a lot like combining like terms, but we have many different terms within the parentheses. To be a like term, they must have the same exact letter and the same exact exponent. For instance, 5x and 2x in the first example would be like terms, but 5x and 2x squared would not be like terms because they have different exponents. To underline like terms, I'll use different colors. So we see a 5x over here. Let's look around, see if we see another term that has a single x. We see a positive 2x. Now, let's choose a different color to see if we have any other x squareds. We have a 2x squared here. We notice we have a negative 8x squared over here. It's important to keep the sign with the number that is after it. Constants can be combined as well. So we have a negative 2 and a positive 2. When we go to add up like terms, we need to look at the 5x and the 2x, and when we add those, we get 7x. When we add like terms, we add the numbers in front of the like terms, but keep the variable and the power the same. It's like a label. Looking at the x squareds, we have a 2x squared and a negative 8x squared. 2 plus negative 8 is negative 6. So we have negative 6, and we keep our x squared. Lastly, we have the negative 2 and the positive 2, which is actually just 0. Now, your ECA won't write plus 0. They'll probably erase this completely from the answer. Adding 0 doesn't really do anything. From the very beginning, you can choose to cross out those 2's if you would like. So we can go in and cancel them from the beginning because one's a negative and one's a positive. On your ECA test, they may not have this exact answer written down. They may go in descending power order, which means they put the 6x squared first, which is a negative, and the positive 7x second. They work their way down from the highest power of x, being 2, to the lowest power of x, being your invisible 1, which you may or may not draw. Either way is acceptable, but you don't have to draw it for your final answer. Let's move on to one that involves subtraction because they're slightly different. We're going to take a look at number 6. So you'll notice the subtraction sign in between the two binomials. Now it doesn't really matter about the subtraction signs that are inside the binomials. We're mainly focused on this one between them. Now this subtraction poses quite a problem for us. Instead of having to subtract all of that stuff that's in the parentheses, it would be a lot easier if we made this similar to a problem we already know how to deal with: addition. We can zoom in a little bit more. Alright, so we can go ahead and make this an addition sign, and let's use a different color, like red. And it'll make it quite a bit easier for us. That will change all of the signs in the parentheses that follow. You'll remember this from MATLAB B. Change the sign, change what follows. So this 8 will change to negative, negative 7 will change to positive, and positive 3 will change to negative. Notice we didn't change the signs in the first set of parentheses because they did not follow the negative sign. Now, to add like terms, we'll underline the positive 6 end of the third, the now positive 7 end of the third, the n squared, the now negative 8n squared, and the negative 4, and the now negative 3. A 6n to the third plus 7n to the third is 6 plus 7, which is 13, and keep the n to the third. The n squared has an invisible 1 in front of it, indicating there's 1 n squared, which we're going to add to our negative 8n squared. A 1 plus a negative 8 gives us a negative 7, and we keep the label n squared. The negative 4 plus the now negative 3 is a negative 7. Looking at this, we have the highest power of n in the beginning, and we work our way down with the second highest power of n, or biggest exponent, down to the constant. So our answer is final and simplified. We're going to look at one more that steps it up one more notch. Number 9 is a perfect example because it involves multiple steps and multiple polynomials. Looking at the subtraction sign in between the first and second polynomial, we need to change that to an addition sign, which means we need to change everything that follows. Now, this subtraction sign was only going towards the second polynomial out of the 3. Since we changed the sign before the second polynomial, we only need to change what follows in the second polynomial. Hence, this last polynomial will not change, but the signs on the second one will all change. This negative 8 will become a positive. This positive 6 will become a negative. And this positive 7 will become a negative. Combining like terms might be a little tricky, so take your time here and use lots of different colors. So we have negative 8a squared. We do not have any 8 squareds in the second polynomial. In the third polynomial, there is a 2a squared. We have a negative 8a. In the second set of parentheses, I'm going to go ahead and erase that a little bit, make it a little neater. As I was saying, in the second parenthesis, you have a negative 6a. And in the third parenthesis, you have a negative 3a. Let's pick one more color to use. In the first, you have a negative 4a to the fourth. In the second, you have a now positive 8a to the fourth. And there's one more term to account for, so one more color. We have a constant over here, a negative 7, and a constant over here, a positive 7. You'll notice since one is negative and one is positive, you can cancel those right away. Now going back to what's left to add up. We have a negative 8a squared and a positive 2a squared, which is a 6a squared. In red, we have a negative 8a and a negative 6a and a negative 3a. Negative 8 plus negative 6 is negative 14, plus negative 3 is negative 17. So we have negative 17a. For the a to the fourths in blue, we have negative 4, a positive 8, and that's it. So negative 4 plus positive 8 is a positive 4 a to the fourth. Our last terms are the constants. Don't forget them. Oh, yeah, they cancel. Okay, so you handled that fine, I bet. We have a squareds, we have a, and we have a to the fourths. We've covered everything. We need to make sure they're in order like the ECA will have them, in descending power. So with the highest power of a to the fourth, we're going to have to put that first, 4a to the fourth. Our second highest power is 6a squared. So we're going to put plus 6a squared. And our third highest is 17a. And we were left with no constants. This would be our final answer. I believe you've now mastered adding and subtracting polynomials by combining like terms. If you have any questions, feel free to ask me. I hope you have a nice evening.